Hello, good evening, guys. So, this is Dr. Pooja, and today I'm going to talk about all the equation of motion, right? So, this is for class 9th physics, and here you go. Just a second. Let me see if this thing is working. All right. So, I have all my gadgets ready to. Okay. So yes, guys, my name is Dr. Pooja Sharma, and I teach you guys science on Unacademy. All right, and today's lecture is all about all those graphs that you guys find very difficult to understand. All those graphs from which we, derive the motion equations. All right. So we'll talk about position and time graph, we'll talk about velocity time graph, and we will also discuss how to derive all those equation motion from those graphs, right? So let's get started, let's crack it. All right, so here you go. What will we study today? As I said, this is your chapter 8 from your physics, and we'll be understanding motion equations. Okay, I will not get into the details of what is distance, displacement, what is speed, what is velocity, what is acceleration, and because we have covered all those topics multiple times in your class. All right, so here we will basically focus on all those motion equations and where can we use them, how can we use them to calculate or solve the numerical problems. All right, so here we go, let's get started. Hold on. So yes, if you don't know me, my name is Dr. Pooja. I've done a PhD in biotechnology, and I was a scientist in the United States of America, and also a lab director there. Right now I'm basically teaching you guys science, which includes physics, chemistry, and biology, everything on Unacademy's platform. And guys, just for your help, just for your understanding, if you find these three subjects difficult, then I have launched a course for you, which is my revision course, and that started on October 5th, and we are going to cover physics, chemistry, and biology in much more details in that course, and this course will be ending somewhere in December. Okay, so if you want, and this is not just a revision course, it is going to be a super exciting coverage of all your important chapters of physics, chemistry, and biology. One more time with me. Okay, hello Seth, how are you? Hope you are doing great. So today we will be talking about motion equations, and I'm sorry I forgot to type my code, which is PS13. Hello Yuvraj, how are you? So if you want to go ahead and sign up for my course. Okay, great, very good evening to all of you. So you can go ahead and sign up for my revision courses. Okay, so yes, today we will be talking about ma'am, when will mental quiz will start? Yuvraj, I'm not sure about that, when will that start, but this is like my session on motion, and I will be covering all these. Why it's not working? Hold on. There's some issue with this. Hold on, guys. I guess there is some problem with this, and I will have to reopen it. I hope it works this time. Very good evening, Sumi Shukla. Okay, now we are online again, and the things are working. Okay, let's get started, guys. Mentor quiz. This is not. I'm not going to conduct any quiz here, Yuvraj. I'm great, Sumit. I'm great, and hopefully you're doing good too. So I'm not going to cover, as I said, any quiz here. So if you are waiting for any quiz, maybe some other live sessions are going to be there for your quiz that you are waiting for. This one, in this chapter, I'm going to cover all my important, formulas and on motion, and what are the position, time graph, all those things I will be covering. Okay, so let's get started with the position time graph first. Let's have that, just a second. So first of all, we'll talk about position time graph. So I assume like you guys already understand what is wait a second, what is speed, what is velocity, right? This is class 9. So no, this is not a Menti quiz. Is this working? Can you see this? I'm facing issues with it. Not in my class, Arpit. Thank you, Rashmi Jaswal. Wait, guys, there is some issue with this. Okay, so this is what I was talking to you guys about. Like, by this time, I guess you already understand what is there's some issue, guys. I'm so sorry. Is it working? Is it playing? Can you see things moving? I don't think so, because see, it is not allowing me to write anything. They have put some good graphics in it. So I don't know guys, there are some issues, but anyways I will just keep on discussing. So I assume by now like you guys understand what is distance, what is displacement, then you also know what is speed and velocity, right? All these things you understand, right? So from here, as this lecture is all about understanding the motion equations, so for that, first of all we will start with a distance time graph, right? Let's assume we have this graph. So along this axis we have time, along this axis we have the distance covered by the object. All right, and now in this graph, if we have, let's say, a line passing starting from 0, from this graph we can tell at a given time, let's say this time is in seconds, and the distance is in, let's say, meters. Okay, 5, 10, 15, 20, 25, right? So from this particular graph we can say what is the speed of the object. Okay, so how can we say that? Just we will plot the distance against time. Okay, so it will be distance by time, right? And we can calculate the speed of the object, right? So this is the very simplest, very basic graph that we have, that we use in our physics. All right, so now we know that we call distance covered there is some serious issue with this thing. I'm so sorry guys, it is just the system is not supporting me today, but that's okay. I will still cover the whole chapter for you, okay? So don't worry. We'll go a little slow, but we'll cover the whole thing for you. All right. So that was a position time graph. Now what about having a, let's say, velocity time graph? Okay guys, so we know velocity is what? Velocity is, we call displacement covered in a given time, right? So whatever distance, let's in an easy language I would say distance covered in a given time, but if that distance we also mention the direction of the distance covered, then we call it velocity, right? So here if we have initially in the previous slide I showed you the position time graph, okay, where we can calculate the speed and where we can also from the graph can see where is the object at a given time, okay, from that graph we can tell the position of the object, okay. Now what are the uses of this velocity time graph? So let's say we have a graph like this. On this axis we have its velocity, on this axis we have time. So now guys we have to understand two things. One, if the velocity is uniform, what do you mean by that? That in a given amount of time, okay, its velocity remains to be the same. Velocity is not changing, whether it's 0 time and let's say 5, 10, 15, 20, 25. So over here we have it in meters per second. That is our velocity. Like the object is moving 5 meters per second or 10 meters per second. Alright, and on this side let's say we have time and let's say it is in a 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6 and so on, right? And from this graph what do we get? Let's say if I draw, let me change the color. Let's say if we get something like this, let's say we have this kind of a graph. From this what do we understand? We understand the object is moving with a uniform velocity. So what is uniform velocity? So you will see from this graph at 0 time object is moving with a velocity of 15 meter per second. In 1 second, let's say it is in seconds. In 1 second it is still moving with the same velocity. In 2 seconds it's still moving with the same velocity. 3, 4, 5, 6. That means the object is moving with the same velocity. Hello Junu, how are you? Oh guys, yes, you all are there. Junu, Pavan, Priyanshu, Sumit. Hello guys. Actually, I am facing some issues with this particular template. So there was some kind of, maybe inconvenience to you all. But anyways, I have fixed it and I have decided to just keep on working on this particular sheet only so that I don't have to keep on restarting my presentation. All right. So from this graph, we get an idea like, that velocity is same velocity. And how much is the velocity here? 15 meter per second. Every second, hello Soumya. Every second the object is at the same velocity, 15 meter per second. Right, so this is the graph which we call velocity time graph, because on one axis we have velocity, on another axis we have time, and we have this graph that we have created. And now from here let's understand one thing. If we want to say an object is moving with this much velocity, 15, hello Tanvi, hello, is moving with a velocity of 15 meter per second, right? What is the displacement? Or in very easy terms, I would say, what is the distance covered by the object in this time? Okay, between 2 to, let's say it is 5. Just excuse my drawing. Okay, what is, how far the object go? Okay, if we want to calculate that very easily, we can do that from this velocity time graph if the object is moving with the constant or uniform velocity. How do we do that? We know that velocity is equal to distance or displacement by time. And if you want to cover what is the distance, we'll say distance covered by the object is velocity into time. So the velocity is 15. And what is the time? 1, 2, 3. 3 seconds. 40, I'm sorry, I'm writing on myself. I will write on the other side. So we say distance is this much. So distance is equal to V into T, which will be velocity is 15 and time is your 3 seconds. So it will be 45 meters. How do we do that? What did we do? We multiplied this side with this side, right? And if we say that is the area under this, right? So from this we can say that in a velocity time graph, if we want to calculate the velocity, again samjha do. Okay, I will tell you what velocity is. Okay, so velocity, what is velocity? First of all, we need to understand again the same issue. Oh God, I'm so sorry guys. I don't know why this thing is not working. This is going crazy. Vipin, it's been a while since I have started the class. Okay, so you want to understand I'm so sorry guys. I'm really sorry about this thing today. I'm not going to use it again. My system is crashing again and again. I hate it. I don't know how many times do I have to restart it. But that's okay. I'm not giving up that easily. Okay? We'll keep on doing it until we finish this chapter. All right, I got it. So here now I will explain what is velocity as asked by you guys. Okay, now I will rub the thing. I will not go on to the next sheet, because when I go on to the next sheet, then it causes issues. So we know that velocity, if you know, let's say there is a point A and you go to point B, right? There are two ways. Either you cover all this or you go directly, right? So this is the distance, and this shortest distance is called displacement. All right. So velocity is what? Displacement over time. And speed is what? They are both the same. Distance over time. Okay, they both have same unit, meter per second. Okay, somebody asked it, so I had to answer it. Anyways, so we were okay, so now I will discuss velocity time graph. We have discussed, right? So if we have velocity time graph, in the previous slide we talked about velocity time graph when something is moving with the uniform velocity. But if something is not moving with the uniform velocity, let's say uniform velocity is what? This is the graph, this is the velocity on this side and time on this side, and something is moving at this velocity. Velocity is not changing, right? So this is called object is moving with the uniform velocity. But now let's say we have another object. Okay, now let's say we have another object, but it is not moving with the uniform velocity. Its velocity is changing. Okay, let's say we have velocity on this axis and time on this axis, right? It starts from 0 and that could be its initial velocity. Let's say here is the time in seconds: 5 second, 10 second, 15 second and 20 second. And let's say on this axis we have its velocity, which is like initially it was moving with the 20 meter per second, then 10 meter per second, 20 meter per second, 30 meter per second, 40 meter per second and 50 meter per second, and the time is in seconds. So this one is not non-uniform velocity, because every time the velocity is changing, and when the velocity is changing, that rate of change of velocity, rate of change of velocity is what we call acceleration. So from this graph we will say object is accelerating, right? And if the object is accelerating and we want to understand what is the acceleration, so at any given time and at any given point, whatever the velocity is will give us an idea of its acceleration. Let's say this was its initial velocity. We denote initial velocity with u. Let's say it was 0, right? We want to know its acceleration at this point, right? So when we want to do the acceleration at this point, what do? Rate of change of velocity, which means what is the change in velocity that happened over this period of time. this period of time. That will be our acceleration. So v is the final velocity, u is the initial velocity, and t is the time during which this change has happened. I will write it on this side. So let's say a is equal to v. We will take this 40 minus initial velocity is 0 and time is 15 seconds. So 40 by 15 is the acceleration. So this is a non-uniform velocity. Then it is having a given acceleration. Okay, because it's a non-uniform velocity, only then we have this acceleration. Now what you have to understand, the slope. So we have this slope. Okay, so this slope is what? Is the acceleration of the given object. Okay, so more steeper the slope is, more acceleration is there. Okay, let's say we have another object which is moving with a different velocity. Okay, let's change the color of the ink. And if that object is moving like this, that is more steeper. That means it's accelerating high. Its acceleration is low as compared to this one. And let's say we have another object. We have object number 3, which is like moving like this. What would we get from this graph? First, its velocity was changing very fast. Then velocity did not change very fast, and after a point there was no change in the velocity. Okay, the object is moving at the same velocity. So just from the graphs we can tell so many things. We can infer so many things like what is going on. All right, so now let's take another very interesting topic. How do we calculate the displacement using these velocity time graphs? All right, so for that I will have to erase this all, because I will not take a chance of going to the next slide. Because when I go to the next slide, what happens is it does not start. I'm sorry. Just a second. All right. So now I will have, I'm so sorry, this pen tab is not very friendly to me. On this axis we have time in seconds. On this axis we have velocity, meter per second. We know all the units, right? And let's say this object is moving with the uniform velocity, and I will give it some other color. Let's say this object is moving with the uniform, not non-uniform velocity. Okay, it has some kind of acceleration. At every point, let's say every point, its velocity is changing. That's 0, 1, 2, 3, 4, and 5, and so on. And on this side, its velocity is changing. 10, then we have 20, then we have 30, 40, 50, and this is in meter per second. So now from this graph we want to calculate what is the displacement, right? If that is the question, if we want to calculate what is the displacement, how do we calculate it? Okay, so let's say we want to calculate the displacement from here to this point 4. Okay, let's say this is point 4. So we want to calculate how much the object moved from time 2 to 4 seconds. All right, if that is the thing, what we will have to do is, otherwise what we do velocity into time, and that gives us the distance or displacement. But here what we will do, we have to calculate the displacement from 2 seconds to 4 seconds, right? That is what I said. We have to calculate the displacement, how much the object moved from here to here in this given time t. Okay, so what do? Displacement is equal to this is the area that we will take now. This, the area under this rectangle and area under this triangle. Okay, that will be our total displacement. Okay, so how do we do it? Area of the, let me change the color. So we do it, it is like the area of the rectangle plus area of the triangle that we have, right? So of rectangle will be both the sides, like this side and this side. Okay, so this is 20 into 2 plus area of triangle is half of one side, and that is 2 into half of this side, which is 20. So this is how we calculate, the displacement. Now comes the most interesting topic where we talk about, the motion equations. All right, that is the most interesting topic that we do. So I will erase this whole thing one more time. Okay, and now let's discuss what is your motion equations. We call them kinematics as well. So we have technically 3 equations. Okay, so first of all, we'll have to understand, we will go with the example where the object is having some kind of acceleration. Okay, so I have erased it, but that 25, 45, which 25, 45 are you saying? So object is moving with an acceleration. So let's talk about, this topic. So we have to, let me draw anyways, I cannot draw the shapes, so we have to draw this. Now we are calculating the equation, motion equations. Okay, here on this side we have velocity, here on this side we have time. Okay, and that object is accelerating. So for that, let's say this is the zero velocity, and on this we have time t, and somewhere here we have the object reached velocity v, and it started with the velocity u, and velocity is in meter per seconds, and your time is in seconds. All right. So let's say the object, when it started moving, it had some initial velocity. Okay, here is the object which is moving in that direction, and it has some initial velocity which it did not start from zero. Okay, so it is not having a zero velocity, it is having some velocity. So now what do we do in these motion equations? So we want to calculate, let's see, I'll give an example. For example, there is a path, okay, and there was an car, and there is a car over here, okay, and it starts from this velocity which is u, and it reaches here, and here its velocity, final velocity, is v, right? It is moving with certain velocity, certain acceleration, change in velocity is happening. All right, so we want to calculate what is this new velocity, means what is this final velocity, what is the distance covered by the object from here to here, right, and how much time is taken by the object to move from position A to position B. So that is why, if we have all these queries, that is why we have these equations of motion, and that is the whole idea of today's lecture. We want to understand what are these equations of motion. All right, so let's get into these details. Here we want to calculate what is v, what is the final velocity of an object if it starts with initial velocity of u, right, and it has some acceleration. Then we will also want to calculate what is the distance covered by the object, okay, and the third point we would love to do is what is the time taken by the object to reach to that point. So these are the three major topics that we will be covering in this lecture now, and let's do it. Okay, so first of all, I will just erase this, get rid of this part over here, we don't need it. I have already explained like what all will be calculating. Hold on. Okay. Now what do we have here? We said it starts with the velocity u, it reaches a velocity v. Okay, now we have to first of all calculate what is this final velocity, which means initial velocity. We want to calculate it somewhere around here at time t. At time t, if we say this was the initial velocity at time t, and this will be the final velocity at time t, right, over here. So this is what we will draw at first. So we know that acceleration is what? Change in velocity. So how much change is there? Change in velocity is what? V minus u, means the total velocity, this was total velocity, right? This thing, whole thing was v. We have to subtract u, this one, and that will be from total velocity. If we subtract u, that will be our acceleration, rate of change of velocity. Okay, so let me get rid of this. All right, so now we'll have to calculate v minus u by t will be our acceleration. And now what is v? If you do a little bit of algebra over here, we will find v is equal to u plus at, because this t will go on the other side. So when this happens, this is our equation number 1. We have calculated. V is equal to u plus at. And guys, here you have to take care of one more thing. Okay, if we talk about v is equal to u plus at, so what are we doing here is, let's see. So this is u, right? So v is what? U plus this one, which we are saying is a and t. So that is why this v is u plus this a t, right? So that is the, हाँ विपिन, that is what I am telling you कि कैसे पता चलेगा कौन सा फॉर्मूला लगाना है. Let's say they are saying an object is moving with a velocity and it is accelerating. The initial velocity is this much and find out the final velocity after time t. So when it says find out the final velocity, like after some time where the object is, right? If it says find out the final velocity, that means it's asking you to find out this. It's asking you to find out what is the value of v, and we have calculated it. We know that v is equal to whatever the initial velocity is plus whatever the change in velocity, because if I break it open, if I break this at open, this one, what is it exactly? At is equal to what? Velocity per unit time into time. So this will cross out. So actually it is final another velocity over this period of time, right? So it is initial velocity plus a into t. That is the formula to calculate what is the final velocity of the object. Okay. Now we have calculated our formula number 1. Right? Hello, hello, hello. Amazing videos by Vaibhav. Now we will do our second equation. I've done it. Now let's do second equation. Let's say if the examiner want us to calculate the distance, value of s, or the displacement, right, over the period of time t, right? That is what we have to do. Over the period of time t, we have to calculate what is the total displacement. What will be the formula for that? We have to talk about it. Okay, so let's do it. How do we do it? We know that actually we have to calculate this whole thing, right? That is our distance. So we know that s is equal to area of this rectangle plus area of this triangle, right? That is what we have. This is kind of a triangle that I have, this area, and this is kind of a rectangle. So we have to plus both the areas. So now area of rectangle is area of rectangle, let me see, the area of rectangle is this one, base into height, right? So base is what? T into u, right? Plus area of triangle. Area of triangle is what? Half into one side, one side is what? If we talk about area of triangle, area, one side is this t into another side, this is another side, at. So if you calculate it, this is equal to ut plus half at squared. So this is what your equation number 2 is. So we have successfully calculated two motion equations. Like if somebody asks us to calculate final velocity and somebody asks us to calculate the distance. Now let's say if somebody asks us to calculate what is the time taken, what will we do, right? So what we will do, simple, very simple. We will use the same thing, but this time S is equal to the displacement. We will calculate the area under trapezium. Okay, this is what we will do to make it simple, to make it easy. This is our third equation we are calculating. So what is the area of trapezium? It is half, okay, into base into h1 plus h2. So here we have, I'll just delete this thing because it's coming in my way. Okay, so let's do it. So half into b, base is what? Base is our t into h1, height 1. What is our height 1? What is our height 1? U is our height 1 and v, which is the, so this is u and this whole thing is v. h1 plus h2. So one side and another side. U plus v. Okay. And now we have to insert the value for t, and that we will do from this equation. Okay. And t will be v minus u divided by a. This is what we will take. Okay. So if we insert the value, it will be half v minus u by a into u plus v. Are you getting my point? And when we solve it, what do we get? S is equal to half v square minus u square divided by 2a, and this will be 2as is equal to v square minus u square, and this is our equation number 3. Okay, so now you see how we calculated all these three equations. Menti, this is not a Menti quiz class, right? I will tell you Malati Prabha. So let me erase this whole thing. Okay. So now you are saying, how do we know? So that is the question that everybody asks. Okay. So this is the question. How do we know which formula to use? First of all, you need to know that the object is moving with uniform acceleration. That is point number 1. Okay, they have to tell you like this is the object and it is moving with a uniform acceleration. So uniform acceleration means it is having some change in velocity. So guys, you have to understand the relationship between distance, velocity and acceleration. You have to understand this thing, that is point number 1. Okay, so what is the relationship between these three? Rate of change of distance or displacement is called velocity, rate of change of velocity is called acceleration. So that is the relationship between the distance, the velocity and the acceleration. And if I'm saying something is moving with the uniform speed, so that means it's moving like this. This is the speed and it is not changing, right? This is called an object is moving with the uniform speed. Now let's say, and there will be no acceleration, right? Because acceleration is what? Final velocity minus initial velocity in a given time. But here final velocity, initial velocity at any time is same. If say we have 0 time, 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, it is not moving from here. It was like 0, 5, 10, 15 meter per second. It was always at 15. So there is no change in its, let's say, velocity. So its acceleration is 0, right? V minus u by t, right? So this is a uniformly moving item. Now let's say the object is moving with, there is a change in velocity, but that change in velocity is happening uniformly. The object is moving like this. The object is not moving like this. Then you will not be able to use these motion equations. Okay, these motion equations you use only when it says there is a uniform acceleration. The object is moving with a particular velocity and the velocity is changing. So these are the conditions, first of all. Second is your question. But मैम अपन velocity को और क्या, velocity को आप speed भी बोल सकते हो, but that is when it is with the direction, then it is called velocity. Otherwise velocity and speed, they don't have any major difference. Speed is a scalar quantity, velocity is a vector quantity, right? So when to use these equations? So when we want to know the final velocity, then we use V is equal to U plus AT, because V is the final. When in the question it says find out the final velocity, or let's say it says what will be the velocity after 10 minutes. So from the question you need to understand whether it's asking at what velocity it started moving, or whether it's asking when did it, like when was the final velocity, what was the final velocity at a given point of time. Then you will use this formula. Okay, if it is asking you what is the final velocity or what is the velocity of 10 minutes, or an object was moving with this velocity and after someone applied the brakes and the velocity decreased, what is that decreased velocity? So anything related to final velocity, you have to use this formula, V is equal to U plus AT. Now let's say it says, that is 1. Let's say it says what is the an object was moving with this initial velocity, this final velocity, how much distance is covered in a given time. When it says how much distance is covered, then you use this formula, S is equal to ut plus half at square, when it says what is the distance covered by the object. Now third, when it says this is the final velocity, this is the initial velocity, in how much time object will cover a distance of 10 meters. If it is asking the time, okay, then you will use this formula, which is V square minus U square is equal to 2AS. So from here somewhere you will calculate, okay, what was the final velocity, what was the initial velocity, what is the distance, what is the acceleration, then you can find out the time easily. So this was all about today's lecture, and this was all about, you know, how do we use and where do we use this equation motions, right? Yes, All right. So with this, I will just end this session because my this thing is not working properly. So guys, we have covered this lecture, and somehow there were some issues in the PDF itself, and I'm not able to show you all the slides, but we have pretty much covered the topic which I was supposed to cover. Okay, so with this I would end this session, and you guys have a wonderful time. Thank you so much, and good night. Okay, I end this session here. It did not support me today very well, so I'm sorry about that. It seriously did not support me very well today. Every time I hit these buttons, it threw me out of the screen. But anyways, it's letting me do it now, so I'll just quickly. So these were the sheet I was supposed to use for you guys, but anyways. So you can ask me anything: what, why, where, when, who, how, or you can, use my code to sign up for, all these great options. And here is, you can take the subscription, you can use my code, guys, as I'm telling this again and again. My code is PS13. If you want to learn with me, go ahead and use this code. I have launched a revision course on Unacademy, and you can be part of my revision. Yes, weapon class is over. You can be part of my revision course and use this code and find me on Unacademy. Here is my name, and I will be able to help you with all your questions and queries. All right. So with this, I end this session. Here are the different plus and iconic options for you that you can join, and apart from this, we have a creative corner as well on Unacademy. Not just the academics, you will learn tons of other things with us. Okay, so that is it for today. Go ahead and like us. Here is, you can download the app, right? So this is all about today's lecture. You guys have a wonderful time. Thank you so much for being present in my class. All right, thanks and have a wonderful time.